Thank you for joining me today. Today we are going to be looking at analytical geometry revision. We're going to be revising some of the key concepts that you need to know for the final exams. When we look at analytical geometry, there's quite a few little topics within this big topic. We look at distance formula, gradients, equation of a line, midpoint formula. There's also angle of inclination, equation of any circle, and equation of tangent to a circle. Today specifically, we're going to mainly focus on the first ones, which is distance, gradients, equation, midpoint, and angle of inclination. By the end of the lesson, we're going to look at perpendicular lines, gradients, tangents, and tangents to circles. Remember, often in analytical geometry, you are applying some of the Euclidean geometry properties to answer the questions. Then we're going to use formulae to calculate coordinates, midpoints, and unknown values. Some of the key words that you see often being used in analytical geometry, another word for analytical geometry is often coordinate geometry, and that's the branch of geometry where geometric figures are described using algebraic equations. So in other words, it's geometry on the Cartesian plane. A slope tells us the measure of the steepness of a line. It's often denoted by m, which is the gradient. Equation of a straight line is given by y is equal to mx plus c, where m is the gradient and c is the y-intercept. The angle of inclination, that's the angle that a line makes, it's an acute angle that the line makes with the positive x-axis. So it's that angle there measured in an anti-clockwise direction. Okay, we often call it theta or beta or some other Greek letter. All right. Some of the key mistakes that learners make when they approach analytical geometry is not understanding perpendicular lines. Remember, the product of the gradients of perpendicular lines is -1. Parallel lines have equal gradients. Those kind of concepts, when you confuse them, you can make mistakes. We need to learn to practice working with our formulae and identifying and applying geometric concepts to solve problems. And really, when we get geometric diagrams, they can be quite intimidating, they can be daunting, but you need to extract as much information as you can to help you to solve a problem. What should you know to be able to do from grade 10 and 11? Finding gradients, parallel and perpendicular lines, and finding midpoints are key things that we continue. Today, really, as I said, we're going to look at improving how we approach exam questions and how we analyze diagrams. And we're going to be looking at some of the key areas where you have problems. Learners often struggle with correctly writing and manipulating equations of lines in different forms. And again, all of this really comes down to practice. Sometimes there's errors in arithmetic, and that means we really just have to be careful not to make any careless mistakes. Remember to time yourself in an exam, work and practice past exam papers to help you with that. And difficulty in translating word problems into mathematical equations. When it's a diagram, it becomes a little bit more tricky because you've got to transfer diagrams into mathematical equations. And really, some of the exam problems we see with writing an exam is issues related to time management, understanding exam type questions, and presenting your questions clearly. And that all gets better the more you practice past paper exams. Okay, we'll take a quick break and we're back after this. Hello everyone, welcome back. So we are looking at analytical geometry. We're revising some of the key concepts you need to answer this section in paper 2. Some of the key areas that you need to remember from grade 10 and 11 is gradients, midpoints, and distance formulae, and equations of lines. And then of course we will look how gradients affect angles of inclinations as well. Let's have a look at our first example. So in this question, they gave you that ABCD is a quadrilateral, so it's just a four-sided shape. They didn't give you information about what type of shape it is. They've given you the vertices that they've pointed out on the diagram as well, A, B, C, and D. And they asked you to calculate the gradient of AC. All right, so it's a quadrilateral. We need to start thinking about all the formulae that comes along with straight lines. So there's gradient, there's midpoint, there's equations of straight lines. Now remember, Your formulae are given to you on a formula sheet for your gradient and your equation of a line and your midpoint, but if you haven't been applying them by practicing questions, you won't know when to use them, okay? So very important is to focus on your underlying concepts, look at your diagram, see what information they give you, and then that helps you to decide what formulae you are going to potentially use, okay? We don't want to remember the formulae, we want to know when to apply them. And we get to that phase, to that stage where we know when to apply formulae by really practicing lots and lots of questions that are similar. So the first question was to calculate the gradient of AC. So we have a look at AC. It's not joined on the diagram. It's opposite vertices of this quadrilateral. When they ask us for the gradient, we should know straight away, without even looking at the formula sheet, that gradient is equal to y2 minus y1 all over x2 minus x1. The only place that you can really make mistakes here is in your substitution. What's important is that you choose an x1 and a y1 coordinate and don't swap them around between the numerator and the denominator. So if I say that this, for example, is x1, y1, and then this is x2, y2, I've just got to make sure that I work in the correct order. If you don't work in the correct order, that's when you can mess up the gradient. Okay, so to work out the gradient of AC, we're going to start with y1, which is, or y2, it doesn't matter which way you start, as long as you use the same one consistently. You start with the same coordinate consistently. So y2 is minus 5. And then y1 is 1. So we use brackets to make sure we don't make any mistakes with signs. And then it's x2, which is minus 1, all over x1, which is 5. Okay, let's simplify that. Minus 5 minus 1 is going to give me negative 6, all over minus 1 minus 5 at the bottom, that's going to give me negative 6 as well. So my gradient for this line AC is 1. Negative 6 divided by negative 6 is 1. So therefore the gradient of AC is 1. Okay, let's have a look at the next one. Remember, in these types of questions, often multi-steps. There's lots and lots of parts to analytical geometry questions. Now they ask us to work out the equation of AC. So we're working on the same line that we've just worked out the gradient for. So we already know in y equals mx plus c that we have m. We just worked out that it's 1. So they want the equation of the line in the form y equals. Okay, so how do we do that? We know the gradient of AC is 1. What do we need? We need the y-intercept. How do we work it out? Well, we can use one of the points. It depends which formula you use. We can use y minus y1 is equal to m times x minus x1, and that's the formula to find the equation of a straight line. We can choose the coordinate A or C. It doesn't matter which one we choose. I'm going to choose to work with the coordinates that are positive because it's less likelihood of making errors with our signs. So it's y minus 1 is equal to the gradient, which is just 1 times x minus 5. Okay, simplifying, we get x minus 5. Bring your minus 1 over, so it becomes plus 1. So it's y is equal to x minus 4. Okay, so that's the equation of line AC. Let's move on. Hence or otherwise, show that the midpoint M of BD lies on AC. So we've just worked out that that line was y is equal to x minus 4. They're asking us, well, show that the point M lies on that line. So a few things we've got to consider first here. We don't know what the midpoint is, so how do we work it out? We use the midpoint formula. So we first need to find the coordinates of M. That's the first step. Now, to show that a point lies on a line, and this is the same even when you're dealing with function questions in paper 1. To show that a point lies on a line, you take one of the values, either x or y, you substitute it into the equation of the line, and you should get the corresponding value. So if I'm substituting x in, I must get the y value out. If I substitute y in, I must get the x value out. Okay, so there's two things we need to do here. First, find the midpoint, and then we work out whether the point lies on the line. So the midpoint of BD, we use the coordinates of B and D, the vertices, and we know that the midpoint is x1 plus x2 divided by 2. That gives me the x coordinate. And y1 plus y2 divided by 2 will give me the y coordinate. So let's do a quick addition. So we've got minus 3 plus 9, which is 6. 6 divided by 2 gives me 3. So that's the x coordinate of point M. And then to find the y value, it's 5 minus 7, which is negative 2. Negative 2 divided by 2 is negative 1. So that's the coordinates of point M. 3, negative 1. Now we've got to show that that point lies on the line. So we're using y is equal to x minus 4. I said either use the x and work towards y, or use the y and work towards x. What we're going to do is substitute the x value of 3 in, and if we get out the y value of negative 1, then we've shown that that coordinate lies on the line. So in y is equal to x minus 4, I replace x with 3. Okay. 3 minus 4 gives me negative 1, which is great. So that tells me that this point, 3, negative 1, lies on that line AC, because when I substitute the x value of 3, I get out the y value. All right. Okay, so that's quite a little bit of, quite a lot of information to take in. We've got to know that if I want to show that a point lies on a line, we need to substitute one of the values of the coordinate in and get the other one out, okay? We also saw there that before we could actually work out if the point lied on the line, we needed to find the point, and we had to do that using the midpoint formula. So that's just a recap of what we've done so far. Let's move on to part D. They said show that angle AMB. So again, we need to join A to C. Show that angle AMB, that's the one where the two lines intersect, AC and BD. Show that that angle's 90. Now there's different ways to show that an angle between two lines is 90 degrees. You've got to look at the question, really analyze what you've been given and what you've already worked out, and then choose the most appropriate and, most importantly, the quickest way to get to the answer. So I've got that the gradient of AC is equal to 1. If I want to show the angle at the point of intersection of these two lines is 90 degrees, in my mind I start thinking, well, the quickest way to do that is to show that they are perpendicular by finding the gradient of BD. Because remember, the product of perpendicular lines, the product of their gradients is negative 1. So if I work out the gradient of BD and I can show that when I times it to the gradient of AC, my answer is negative 1, it means that angle AMB must be 90 degrees. So let's work out the gradient of BD. So gradient of AM was 1. That should be a positive. Let's work out the gradient of BD and see what we get. So the gradient of BD is what, or you could use the coordinates of M and work out what that gradient is. It doesn't matter if you use M or D. I find it safer to work with D because we know that it's a given value rather than using one that we worked out ourselves. Okay. But working out the gradient, let's check. It's going to be y2 minus y1 all over x2 minus x1. So 5 minus 7, that gives me 12 over negative 12, which is negative 1. So therefore we get the gradient of BD, which is the same as BM, because remember M was the midpoint of BD, is equal to 1. Now if I multiply those two gradients together, the gradient of AM times the gradient of BM, I get 1 times negative 1, which is negative 1. Therefore, it means that BM is perpendicular to AC, so therefore angle AMB is equal to 90 degrees, because we show that the products of the gradients of those two intersecting lines is negative 1. So therefore, if the product of the gradients is negative 1, that angle must be 90 degrees. Okay. All right, guys, let's take a quick break and we'll be back after this. Welcome back, everyone. We are looking at analytical geometry revision, and we're looking at some of the examples where we're practicing so far gradient and midpoints, equation of lines. We're going to continue with the same question we were looking at before the ad break, and this is just part E. We need to calculate the area of triangle ABC. Now again, there's different ways that we can work out the area of the triangle. We want to use the way that uses most of the information we've just worked out. So we've worked out that angle AMB is 90 degrees, and I know that area of a triangle is a half base times height. So if I knew the length of AC, so that's my base, and if I knew the length of BM, then I could say a half base times height, and that would help me to work out the area of triangle ABC. So we're going to use the formula half base times height. So that means we need to work out some lengths. All right, so let's do that. So if we're looking for BM, remember we've got the coordinates of M already. So using our distance formula, what was the coordinates of M? Let's just quickly go back and check what we had for M. We had 3 and -1. Right. So we're going to use our distance formula, and we'd say BM squared is going to be, using your distance formula, -3 squared plus 5 minus 1 squared. Okay, so that's just a straightforward substitution into your distance formula. When you simplify all of this, you will end up that BM is going to give you the root of 72. So that's root 72. Okay, we now need to work out the length of AC. Again, we use the distance formula using the coordinates of A is 5 and 1 and C is -1 and -5. So we'll get 5 minus 1 squared plus 1 minus 5 squared. So we end up with 6 squared plus 6 squared, which is 36. 36 plus 36, which is 72. So therefore AC will be equal to the square root of 72. So now finding the area, it's going to be equal to a half of BM times AC. It's the half base times height. Okay, that should be 72. Remember, root 72 times root 72 is the same as squaring the root, so therefore we'll just be left with 72. So a half times 72 gives me here that this length is, that this area is 36 units squared. Okay, so we've worked out that the area of this triangle using half base times height is 36. Okay, guys, let's move on to the next example. So in this question, we are given that the equation of the tangent APB, which touches the circle, which has a center at C, is given as that. So they've given you they asked you to find, very important to read nicely and extract the information. Here we asked to find the equation of the tangent. We aren't given the equation of the tangent. Now when you start thinking about a tangent, remember tangent is a straight line. So when they're asking you to find the equation of APB, they're asking you to find y equals mx plus c, which means you need a gradient and you need a y-intercept. This line APB is touching the circle at the point 5 and 3. All this information is given on the diagram. The important thing that we need to remember, when a circle and a tangent meet and the line drawn from the center of the circle meets the tangent, the radius is perpendicular to the tangent. That's an important bit of information. Radius perpendicular to tangent at the point of contact. Why is that important? Because it gives us information about the gradient. Okay, because if those two lines are perpendicular, then it means the product of the gradients is equal to -1. So that's going to be the bit of information that helps us to work out the gradient of tangent APB. We know that the center of the circle C is 3 and -1. I'm reading that off from the given information. So therefore, if I work out now the gradient of CP, just using your gradient formula, it's going to be 3 minus 1. So that's 4 divided by 5 minus 3, which is 2. You get the gradient of CP is 2. Now remember what we said. The product of the gradients of perpendicular lines is -1. So therefore, the gradient of CP times the gradient of APB is equal to -1. So if the gradient of CP is 2, then the gradient of our tangent must be equal to -0.5. Okay, it's the negative inverse of the gradient that you have. So therefore, it's -1/2, or you can work it out using a small equation. Okay, so we've got that the gradient of APB is -0.5. We now need to work out what the y-intercept is, and how do we do that? Well, we need to substitute the point that we've got. So we've got the point of contact is 5 and 3. And we know that the gradient is -0.5. Substitute those values in, so you get -0.5x plus 5/2, and then we take the 3 over to the other side. It's plus 3, and when you work all of that out, you end up with y is equal to -0.5x plus 5.5. 3 plus 2.5 is 5.5. Okay, so what we saw importantly there is that we used information that we had already worked out. We don't try and reinvent the wheel and start all over again. We use what we've got. Okay, let's have a look and see. So when you approach these types of questions, I want to make a note here. Remember that especially in multi-step questions, which this one is going to be, show your steps and calculations, because even if you make a mistake in an initial step, often you may earn a partial mark or some partial marks for demonstrating that you understand. And if it's just a careless mistake, sometimes you do get part marks for the questions. Okay, so make sure to show all of your steps, especially in multi-part questions. So in this one, they say that L is -4. They've given you the vertices of this triangle, and they tell you that angle SLN is 90, which is also marked on the corner there, on the vertice. LN intersects the x-axis at K. Okay, let's have a look at what the first question says. So we'd look at our diagram, we'd see that they want us to calculate the length SL, okay? Now, we note also that because SL is perpendicular to LN, we think about, okay, their gradients. We also think about the fact that this is actually a 90-degree triangle. It's a right angle triangle, so we can start thinking about things like Pythagoras. Okay, we're not sure if we're going to need it, but those are the kind of things we start thinking about. So if I'm looking for SL, which is that length there, we've got the coordinates of S and we've got the coordinates of L. So it makes sense to use the distance formula. So SL squared is going to be equal to x1 minus x2. It doesn't matter if you swap those values around as long as you do it consistently. So it's going to be 4 minus 4 plus 5 minus 1 squared. So that's going to give us 4 minus 4, it's 4 plus 4, which is 8. 8 squared is 64 plus 5 minus 1 is going to give us 4. 4 squared is 16. All right, so that's going to give us 64 plus 16, which is going to be 4 and 6 is 10, carry 1, so it's going to give us 80. So SL squared will be 80, so therefore SL, taking the square root, will be the square root of 80. Now they said leave your answer in third form, which generally means you need to simplify a little bit further. So therefore we can say, well, 80 is the same as what is 80? The quickest way to do it would probably be 4. 4 will go in there, give me 20. Let's do 4 times 20, which will be 2 root 20. Can we go any further with that? 20 is 4 times 5. Okay, so we could have actually gone with 16 here. That would have been the best one to do, but we can go further here. So this will be 2 times the root of 4 times 5. Square root of 4 here is 2, so it'll be 4 root 5. Okay, and we'll just leave that in surd form. All right, so we've worked out that this is 4 root 5. Okay, let's have a look at the next question. Calculate the gradient of Sn. Now for gradient, we're going to use our gradient formula, y2 minus y1 over x2 minus x1. So it'll be 5 minus 3 all over 4 minus 2. So be careful when you substitute, especially minusing negative numbers. Use brackets so that you don't make careless mistakes with your signs. 5 plus 3 on the top will give me 8. Divided by 4 plus 2 will give me 6. So 8 divided by 6, we've got 2 goes into 8 4 times, 2 goes into 6 3 times. So therefore my gradient of Sn is 4 over 3. Okay, all right, so far so good. Let's calculate theta, the angle of inclination of Sn. Now remember, angle of inclination is the angle that the line makes in the direction of the positive x-axis. We measure it in an anti-clockwise direction. So as you can see, they've marked that off as theta. When we work out the angle of inclination, we need the gradient of the line. So we need the gradient of Sn. So we say that tan of theta is equal to the gradient of Sn. The gradient of Sn we just worked out as, let's just have a look, it was 4 over 3. So therefore, to work out the angle theta, we're going to say shift tan 4 over 4 divided by 3. And that's going to give us 53,13 degrees. Okay, so we've got that theta there is 53,13 degrees. Okay, let's move on to part D. They now ask us to find the size of LNS, which is sitting all the way here. It doesn't even look like it's anywhere. It's not touching the axis. So here we've got to start thinking, well, how are we going to find this angle that lies between these two lines when that line itself is not on the axis? Okay, how do we find it? Well, we've got to find other angles to help us get there, right? We've just worked out this one. Theta was 53,13. Okay. If I look at where n is sitting, it's in this little triangle OKN. So that's one little triangle I can see. And I can see using vertically opposite angles, I can get angle O is also going to be 53, or KON is going to be 53,13 degrees. But I need another angle. Where does it come from? We can work it out. We can work out what this angle here is. Okay, and then using exterior angle of a triangle is equal to sum of interior opposite, we'll be able to get what angle N is. Okay, so to do that, we need to first, you see it's a multi-step approach. We need to first work out the gradient of Ln, and then we work out this angle, let's call it beta. Okay, so gradient of Ln is going to be 1 minus 3, so it becomes 1 plus 3, all over negative 4 minus 2. So minus 4 minus 2 would become plus 2. So I end up with 1 plus 3 is going to give me 4 over negative 2. So my gradient here is negative 2. So therefore I can say tan of theta, because now, or tan of beta rather, is equal to negative 2. And that's going to help me work out that angle of inclination of line LN. Using the calculator. Alright, so we go, you can go shift tan of -2, but we can also do 180 minus. So let's do it that way. Shift tan of 2 is equal to 63,43. Alright, so therefore that angle that we are interested in, we can see that that one is not really an acute angle. Okay, it is greater than 90, so it's going to be 180 minus that answer. So it's going to be 116, 57. Okay, so that's the angle beta that we have there. We already know that this angle KON is 53,13, so therefore angle N using exterior angle of triangle is equal to the sum of the interior opposite. We can work out that angle LNS is going to be equal to 116,57 minus 53,13. Let's see what that gives us. Minus 53.13. And that will give us 63,44. So LNS is 63,44 degrees. All right, guys. Okay, so we saw that in this question it wasn't so straightforward. We couldn't go straight in and work out the value of our angle. We had to do a few steps to get there. Okay, let's process all of that and let's take a quick break. We're back after this. Welcome back. We are looking at analytical geometry revision and going through some past paper questions. Before this break, we were looking at a multi-step question and it's not quite done yet. Let's look at the last part. So here in part E, they ask us to determine the equation of a line which passes through L and is parallel to SN. So this is interesting. This line is not drawn, so therefore we need to draw it in ourselves. It's going through L. That's what it's doing. Okay, it's parallel to SN. Parallel lines have equal gradients. Remember, we worked out previously that the gradient of SN was 4/3. So therefore, the gradient of this line that passes through L is also going to be equal to 4/3. So therefore, we know that the gradient in y equals mx plus c, we know that m is going to be equal to 4/3. We need to find the y-intercept. To do that, we've got 1 point. We know that it passes through -4, 1, so we can substitute into our equation for straight line. Y minus 1 is equal to 4/3 into x minus -1, so it becomes x plus 4. Let's simplify. So we get 4/3x plus 16/3, and at the same time let's bring the 1 over, so we get plus 1. So we end up with, let's not forget our x, 4/3x plus 16/3 plus 1 is going to be 19/3. Okay, and that's the equation of that line. As you can see by drawing a diagram, it makes a lot more sense now. We can see where this line is passing through, and the fact that it's parallel helps us to use given information that we've already calculated. All right, then the last part says calculate the area of triangle LSN. Okay, so to work out the area of triangle LSN, remember we already worked out, one of the first questions was to work out the length of LS. So we know that that was 4√5. Okay, we've already worked that out. Now they want us to work out the area of the triangle, which we know is going to be the simplest formula, half base times height. We've got that we worked out LS is 4√5. How do we work out Ln. Well, we can use, once again, we can use the distance formula. So let's work out Ln. So Ln squared is going to be 1 minus 3, so it becomes 1 plus 3 squared plus minus 4. I've just swapped the x and the y's around, but it's fine in this case. So it's going to be minus 4 minus 2, so it's minus 4 plus 2 squared. Okay, so 4 squared is going to give me 16, plus 2 minus 4 is 2. 2 squared will give me 4. So this will give me 20. So therefore Ln is going to be square root of 20, which is the same as saying 2 root 5, because 20 is 4 times 5, and when we simplify that, square root of 4 is 2. All right, so therefore my area of triangle LSN is going to be a half into 2 root 5 times 4 root 5, and the 2's cancel, so you end up with 4 times root 5 times root 5, that's root 5 squared, which is just 5. So it's 4 times 5, which is 20 square meters. Okay, all right guys, so that was quite a long multi-step question, and it required quite a lot of concentration, and that's what you need to do in an exam. Concentrate, make sure that you get each step right so that you don't make any careless mistakes, and take them forward into the following step. Let's have a look at the next one. They say in the diagram, they give you the vertices A, B, we've got unknown coordinates, C is 4 and minus 2. This is a triangle that's drawn, and they tell you line BC is produced. Produced just means extended to point H. Cuts the x-axis at E, which is 12 and 0. They also tell you that AB and AC, there we go, intersect at the x-axis as F and G. So basically they're just pointing out the x-intercepts of these lines. The angle of inclination, importantly, they've told you information about angle of inclination. Angle of inclination of AB is 81,87. That's very important, because if they've given you the angle of inclination, it means you can work out the gradient of the line without having the coordinates of B. Because remember, tan of theta is equal to the gradient. Okay, let's have a look at what the first question says. And indeed, the question is part 2 here, asking for the gradient of AB. The first one is to calculate the gradient of B to E. Now remember, they told you BC, it's produced, so that means this is all on the same straight line here. So to work out the gradient of BE, it's going to be the same as the gradient of CE. They are on the same straight line. So gradient of BE, we use the coordinates of C and E, is going to be 0 minus 2, so it becomes 0 plus 2 over 12 minus 4. So we get 2 over 8, which is a quarter. Okay, so the gradient of BE is the same as CE, and that gradient is a quarter. Now to work out the gradient of AB, remember I said to you it's important, they've given us this little angle here. So I can say the gradient of AB is going to be equal to tan of 81,87 degrees. And let's use our calculator. Tan of 81.87 is equal to 7. And you can see it's almost exactly 7 because we follow that with a couple of zeros. So therefore the gradient of AB is 7. All right, and you see that we've worked out that gradient of AB without actually knowing the coordinates of the line of the point B. So the gradient here of AB is 7. Okay, let's have a look at what the next question says. Determine the equation of B to E in the form y equals mx plus c. Now, again, remember, C and E lie on the same straight line as BC. BCE are all on the same straight line. So therefore, if they're asking you to work out the equation of BE, you see they've put B there because it gets a little bit confusing, but you need to look around that and you need to analyze the question and realize, well, I don't really need to work with the coordinates of B because even though they're unknown, I do have known coordinates. Okay, so we worked out previously the gradient of that line BE was a quarter, right? So therefore now the equation, we can use either the coordinates of E or C. Let's use E. So it's going to be y minus 0 is equal to a quarter into x minus 12. So this will be a quarter x minus 3. And that is the equation of this line BE. It's a quarter x minus 3. Okay. Now, it's important information because we likely need this information in the next question, and that's how these multi-step analytical geometry questions build up. And indeed, look at the next one. It says, calculate the coordinates of B where k is less than 0. How do we do that? Remember, B lies on this line that we just found the equation of. B lies on that straight line. So that equation we found was y is equal to a quarter x minus 3. B has the coordinates k, k. So therefore, those coordinates lie on this line. So if I substitute y is k, then I should get out the other value for x, which is k as well. And we substitute into that formula to work out what k is. So we get k is equal to k over 4 minus 3. And as you can see now, we can work out what k is because we've got an equation to work it out. So let's times through by 4. We end up with 4k is equal to k minus 12. 4k minus k is 3k, which is equal to negative 12. Divide both sides by 3, you get k is equal to negative 4, which is great because they said k is less than 0. So therefore, the coordinates of B are going to be negative 4, negative 4. All right. Okay, so that was a long question as well, just like the previous one we looked at. In analytical geometry, often these questions build up. And so it becomes so important that in each and every one, we are really concentrating and making sure not to make any careless mistakes with signs or with anything else. And really, as I keep saying over and over again, the way you get better at anything in maths is by practicing lots and lots of past papers. Okay, guys, I think let's take a break now. When we come back, we'll wrap things up. Thank you everyone for coming back. It's time for us to wrap up our discussion on analytical geometry. In today's lesson, let's recap what we've done. We looked at distance formula, gradients, equation of lines, midpoint formula, and angle of inclination. We looked at some of the key words that were used in analytical geometry, noting that coordinate geometry is the same as analytical geometry. It means it's geometry on a Cartesian plane. Slope gives us the measure of steepness of a line. The equation of a line, we can use y equals mx plus c, and often we use the formula y minus y1 is equal to m into x minus x1 to help us work out the equation. The angle of inclination is the angle that a line makes in the positive direction of the x-axis, and it's always measured anti-clockwise. So if we have a line, the angle that it makes between the positive x-axis and itself is that angle of inclination. Some of the common errors that we hope to have really fixed today is the difference between perpendicular and parallel lines, and using perpendicular lines and the gradients to help us solve an equation and find unknown values. Often, if we don't know the formulae, we don't apply the formulae correctly. So again, practice comes into play. And we saw that if we understand and do lots and lots of past papers, we can solve problems better and interpret our results better because we've seen similar types of questions. Very importantly, when they give you a diagram, you must analyze the diagram. Mark down given information, mark down any information that you can then decipher yourself or that you can deduce from the information that they gave you. All right. Importantly, when you in an exam situation, time yourself, make sure to manage your time appropriately. We give more time to questions that require slightly more work, that are slightly more complex. And remember, as I've said often, you have to work towards a mark a minute. So if it's 5 marks, shouldn't go over 5 minutes. All right. Remember, guys, I've said it over and over again, practice makes perfect. We need to practice exam past papers. We need to go over typical types of questions that can appear in the exam. And therefore, we've got a few practice questions that you can try from past papers. But also, you've got many more, I'm sure, through your textbooks and the schoolwork that you've done during the year. Thank you so much for joining me through this lesson. Take care and good luck. Cheers.